So we're doing OCR paper 5. It's the non-calculator paper, higher tier, and this is from November 2018. And if we just have a look across paper 5, we need 18 marks for a 3, 22 for a 4, 30 for a 5, right up to 79 marks for a grade 9. Question 1, we've just got some number work to do. This first thing's asking for us for the cube root of 64. What number times itself? 3 times is 64, and the answer to that is 4. 4 times 4 is 16, times 4 again is 64. And we're going to multiply by 2 to the minus 1. Well, anything raised to the negative 1 creates the reciprocal of that. 2 to the minus 1 is a half, 3 to the minus 1 is a third, 4 to the minus 1 is a quarter. So we're going to do 4 times a half, which is just a half of 4, which is 2. Part B, we've got some standard form work to do when we're adding numbers in standard form. This is a non-calculator paper. You can change these to normal numbers, so I'd get 4, 3, 0, 0, 0, 0 if I just multiplied this by 10 5 times. And in fact, that's what I'm going to do to solve this question. So 3.8 times 10 once, twice, 3, 4 times. I'm going to add those together using column addition. No, 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 8, 3. Just make sure we're lined up correctly. No, add no is no. So my final answer is 468. No, no, no. Be careful. It says give your answer in standard form. So I want a number bigger than 1 but less than 10. Just using these digits, 4.68. And that would be times 10. 1, 2, 3, 4, 5 times. Part 2, we've got some estimation work to do, and it even tells you here to round to one significant figure. So 606.3 becomes 600. We're going to multiply by 0.3, again just rounding to one significant figure, and then divide by this. 19.93 becomes 20 to one significant figure. How do we do 0.3 times 600? Well, if I do 600 times 3, 3 sixes are 18, and then 2 zeros on the end. So if 600 times 3 is 1,800, then 600 times 0.3, I'm just going to divide this by 10, because the calculation was divided by 10 here. So that's going to be 180 divided by 20. That's the same as 18 divided by 2, which is 9. Question 3, we've got two spinners A and B being spun, and when they spun, the numbers are multiplied together. We just need to complete this table. So I need to do 9 times 4, which is 36. And then I need to do 5 times 9, which is 45. Part B is looking at probabilities from this table, and we're looking at even numbers and prime numbers. And there's the working that my mate Jeff has done. We just need to figure out why this is wrong. So I'm going to look at even numbers first. Even numbers are your 2 times table. So anything in the 2 times table. And that's it. 1, 2, 3, 4, 5, 6. So the probability of an even number is definitely 6 out of 4, 8, 12. Nothing wrong with that, Jeff. If we move on and look at the prime numbers, well, prime numbers you just need to be aware of. They are 2, 3, 5, 7, 11. Anything that you will struggle to divide in your head usually is a prime number. Basically, they only divide exactly by one of themselves. So I'm just going to identify my prime numbers. There's a prime. Prime. 5 is prime, and they're the only prime numbers in that table. So the prime numbers, definitely 1, 2, 3 out of 12. Not wrong there neither, Jeff. He says the probability that an outcome is even O prime is 6 12s added to 3 12s, which is 9 12s. The problem with Jeff's working is he's counted this one twice. Okay, 2 is even and prime. So we could write that in his mistake. Counted 2 twice, and the fact that it says even O prime means we only need to count this once. So the correct answer will be 1, 2, 3, 4, 5, 6, 7, 8 out of 12. Question 4, we're looking at a metal block with a mass of 500 grams and a volume of 125 centimeters cubed, and we're asked to work out the density. Well, density is mass divided by volume, so that's going to be 500 divided by 125. Not too easy straight off, but I can look to simplify this. I know that these will both divide by 5, so I divide top and bottom by 5. 500 divided by 5 is just 100. 125 divided by 5 is actually 25. And then 100 divided by 25 is much easier than this calculation, but gives the same answer. The answer is 4. Because we did grams divided by centimeters cubed, that is my units for density. Grams per centimeters cubed. Question 5 talks about the depth of water being 57.8 centimeters, and it decreases, so that means goes down by 0.3 centimeters every day. It's going to keep going down at that rate, and it says after how many days will it have reached 54.2 centimeters. I think the first thing I need to do is look for the difference in these two measurements. So if I start with that, 57.8, subtract 54.2, that's going to tell me how much the water has gone down by. So 8 take 2 is 6, decimal, decimal, decimal. 7 take 4 is 3, and 5 take 5 is 0. So the water goes down by 3.6 centimeters. It says we go down by 0.3 centimeters every day. So I need to know how many 0.3s go into 3.6. So I need to do 3.6 divided by 0.3. If I write that as a fraction, I'm going to get 3.6 over 0.3. Why would I write this as a fraction? Well, it allows me, just as in question 4, to write a nicer calculation. If I times the top and bottom by 10, I get 36 divided by 3, which is 12. Part B says if the depth of the water decreases at a slower rate, what will that have on the answer to part A? Well, if the water is going down by less amount per day, it's going to take more days to drop to this level. Question 6, my mate Sally has got 30 feet of ribbon. She cut strips of length 2 2/5 of a foot, madness, from the ribbon, and she says she can get 13 strips. What we're doing is taking this 30 feet and sharing it into strips that are 2 2/5. We're seeing how many of these fit inside the 30. So it's a division. It's not straightforward, but it's doable. First thing I'm going to do is change this to an improper fraction. Never work with mixed numbers. 2 times 5 is 10. Add the 2 is 12. And because we were in fifths, we're still in fifths. So now we need to do 30 divided by 12/5. Well, if we use keep, flip, and change from a division to a multiplication, we can now work this out. We're timesing 5/12 by 30, and when you're timesing a fraction by a whole number, you just times the top number. So 5 3s are 15 with 1 0 bolted on the end. and we're still dividing by 12. We need to see how many 12s go into 150. 12s into 1 is 0, remainder 1. 12s into 15 is 1, remainder 3. And 12s into 30, 12, 24, 36, it will be 2, remainder 6. 12, 24, to get me up to 30 will be a remainder of 6. Bit old school, writing remainder 6 like that. But all I'm trying to show is she's wrong. We can only get 12 remainder 6 or 12 and a bit strips from this ribbon. So she's wrong. Question 7. We've got my mate Emily spending £2,400 on holiday. And this is 20% more than she spent last year. And we want to know how much she spent last year. So it's typical reverse percentage question. What we want to know is what she spent in 2016, which we're going to call 100%. In 2017, we know what she spent. It was 20% more than this. So she spent 120%, 20% more than what she spent in 2016. And that came out at 2,400. So if we know 120% is 2,400, what we're looking to do is scale this down to find my 100%. Several ways to do this. I like to just kind of halving to start with, just get a feel for the numbers. 60% would be 1,200. Just halving and halving. I might divide by 3 this time to give me 20%. And divide by 3 on this side. And 1,200 divided by 3 is 400. 20% is useful because I've got 120% here. So if 20% is 400, and 120% is 2,400, then 100% must be 2,400. 2,400, take the 400, which is £2,000. Question 8, and here we've got a table showing number of computers sold in a shop, and we've got from 2015 to 2017. And all we're asked to do is complete the graph using 2017 information, which is here. So we've got quarter 1, 27 computers sold. So across quarter 1, where's 27? Well, it's 10, 20, that would be 30. So somewhere around there, 27. Quarter 2 is 40 computers. There's quarter 2. That's nice. That's bang on 40. Quarter 3 is 30. Quarter 3, 10, 20, 30. And then quarter 4 would be 58. So there's quarter 4. Right up to 50. That would be 55. That's 60. So again, somewhere just before 60 there. And what we do is connect these points up. Part B says Tom adds the 3 results for quarter 1 and he adds the 3 results for quarter 4, and it says the ratio quarter 1 to quarter 4 is 2 to 5. Is he correct? So I'm going to look at quarter 1 first and see what's happening there. Quarter 1, we've got 13, 20 and 27. So let's add those together. And we get 7 add 3 is 10. 2, 3, 4, 5. That would be 60. Quarter 4. We've got 45, 47 and 58. So let's add those together. Five add 7 is 12, add 8 is 20, And then we've got 4, 8, 9, 10, that would be 15. And then we've got the one there. So we've got 150. So what we've got here, quarter one is 60. And quarter four is 150. And we're trying to see if that simplifies to this ratio, 2 to 5. So let's start simplifying this. If we look at both sides, they'll definitely both divide by 10. And you get 6 to 15. These are both in the 3 times table, so divide by 3, 2 to 5. Exactly what Tom says. Make sure you say the word yes, he is correct. Part C, it says make 2 comments about the sales from 2015 to 2017. Just quickly look back at the graph and you'll see what I'm about to explain. We can definitely say that in quarter 4, he sells more. All right, every time in quarter 4, we're at the top of the graph. So he's always selling more in quarter 4. And what we can also say is that the sales increase over the 3 years. The graph is kind of slowly going like this, up and up and up and up. So he's slowly selling more and more computers. And we're going to use that in part D, where Tom predicts he'll sell more than 60 computers in the 4th quarter of 2018. What assumption is he making? That upwards trend is going to continue. Question 9, we've got a formula x equals y squared plus 7. And we're just looking to rearrange it to make y the subject. So I want to get y on its own. First thing I'll do is get rid of that 7. So take 7 from both sides. And we're left with x minus 7 equals y squared. We're nearly there, but we don't want y squared. We want just y. So to undo the squaring, I'm going to square root. And you get the square root of x minus 7 equals y. We've got 2 triangles, A and B. And what we're asked to do first is draw the image of triangle A after a rotation of 180 about 0, 0. And it's difficult to show this using the device I'm using. You'd grab some tracing paper. You would trace triangle A. You would put your pencil on 0, 0, and you'd spin this around your tracing paper 180 degrees, half a turn. And if you do that, your triangle is going to line up right there. Part 2 says draw the image of triangle A after a translation by this vector. Well, when you've got a vector like this top number is left and right, and positive numbers go right, and then this bottom number is up and down. Positive numbers go up, so negative numbers go down. So this is saying move A 2 right and 7 down. So pick any point and just go 1, 2 right, and then 1, 2, 3, 4, 5, 6, 7 down. That there is where the top of your triangle is going to finish. And then we can just draw the triangle. The triangle is 1, 2, 3, 4 down, 1, 2, 3, 4 down, 2 across, 2 across, and then just connect those together. And I've just seen my initial triangle weren't tall enough. It should have been 4 high. So I'm just going to change that now rather than start the entire question again. That's better. And part B says describe fully the single transformation that maps A onto B. So we're going from this triangle to this triangle. Well, first things first, even though it gets smaller, we call that an enlargement. Okay, I know that sounds weird, but even though we're going from a big triangle to a small triangle, it's still called an enlargement. We need a scale factor, and that's saying how many times bigger or smaller is this to this. Well, if we go from 4 high to 2 high, that's scale factor of 1/2. We're halving the triangle. And then the hardest bit to find is something called the centre, or the centre of enlargement. The best way to do this is clear your diagram, draw some straight lines from this point to this point, and I'm going to carry on. So they'll be a bit rough these, but I'll try my best. So just connected those matching points and carried on. I'll do the same with this line and with this point and this point. Connect them and carry on. And then I could do the same with this point and this point, but I'm only going to draw the same line, look. And what I'm looking for is a point where all these lines cross over each other. It's right there, look. That's your centre. So it's -1 and up to 2. So in question 11, we've got a washing machine that we don't know the price of is reduced by 20% and then increased by 30%. And my mate Joachim is saying the washing machine is now 10% more expensive. So this is a combination of percentages. I'm not going to explain this mistake first. What I'm going to do is just work out the actual percentage change. Now, because we've got no price of the washing machine, that's actually a good thing because we can say what we want. And if you're working with percentages, the nicest price you can use is £100. So let's just say that the washing machine starts at £100. We're going to reduce by 20%. So 20% is, well, that's just going to be £20. That's why we chose £100, because you'll just get nice numbers. 10% would be £10, 20% is £20. So after the reduction, we've got £100, take £20, and my washing machine is now £80. The washing machine is then increased by 30%, and it's this here that we're increasing by 30%. So I'm going to do that a bit more slowly. If we know now that 100% is £80, 10% is £8, we want a 30% increase. So I need to find 30%, 8, 16, £24. So after the increase, we've got £80 plus £24, and that comes to £124. And because we chose £100, we've got some really nice maths that allows us to find the correct percentage change. We went from £100 to £124, and that is simply a 24% increase. We can now explain Joachim's error, and the error he made is kind of down here. He didn't increase this new value. Okay, what he was just working on is the original money. Okay, so we can kind of write that. In question 12, we've got part of a circle, the sector of a circle. That just means it's part of a circle. Centre O, radius is 6, and the length of the arc is 5 pi. So this here is the arc, and that we're being told is 5 pi. It says find the area of the sector and give your answer in terms of pi. Well, we can't find area yet until we've got this angle. We need to know how much of a circle we've got, and we're going to need that angle in order to do that. So what I'm going to use is the arc length, and the arc length is given by the missing angle theta divided by 360, that's the full circle, multiplied by pi, multiplied by the diameter. Pi times diameter is the circumference of a full circle. This is the angle we've got, and this is the angles in a full circle. So what we're going to do is work this backwards, because we know that arc length is 5 pi. So we've got 5 pi is angle out of 360 times pi times diameter. What I can do straight away is divide both sides by pi. I can also start to rearrange this equation to get this missing angle theta. So what I'm going to do is times both sides by 360. And 5 times 360, well, 10 times 360 is 3,600. So a half of that will be 1,800. And that is the same as theta multiplied by the diameter. I actually know the diameter. If the radius is 6, then my diameter is 12. So now I can do one more step here to solve this equation. If I divide both sides by 12, I'm going to get my angle theta is just going to be 1,800 divided by 12. This is going to simplify to 900 divided by 6, just halving the top, halving the bottom. And that's going to simplify to, if I divide both top and bottom by 3, I'm going to get 300 divided by 2. And that is the same as 150. So my angle theta is 150 degrees. That is not actually the end of this question. Remember, we're looking for the area of the sector. So what we need to do now is the area. That's going to be theta over 360. So that's 150 over 360 times pi times the radius squared, area of a full circle. And this is the part of the circle I've got. We know the radius is 6. So r squared will be 36. So we're going to get 150 over 360 times 36 pi, just because the radius is 6 and 6 sixes are 36. This will simplify to 15 over 36. If we look here, I'm timesing by 36 and dividing by 36, so that will also cancel itself out. And what we're going to get is 15 pi. Question 13, we've got two triangles, one inside the other. All this information is just explaining the diagram, so work off the diagram more than anything. It says show that AC, this measurement is 20 meters. So that's what I need to find. I think if I look at this diagram, I've got a right angled triangle with an angle and a side. So let's have a look at that triangle. I know that this length is 40. I know that this angle is 30. And I'm trying to work out AC, or show that AC is 20. This looks like trigonometry to me, so let's just label this up. That would be the opposite. The longest side is the hypotenuse. I'm not going to bother labeling the adjacent. I'm just going to write toa, and then figure out which one of these is an hypotenuse opposite question. There it is. So we'll write sine theta equals opposite over hypotenuse. Just substituting in, remember theta is your angle. We're going to write sine 30 equals, the opposite is what we're looking for. Hypotenuse is 40. Now we've got divide by 40 here, so what I'm going to do is times both sides by 40, and you get 40 times the sine of 30 is our question mark. You need to know for a non-calculator paper that the sine of 30 is a half. It's actually telling us that the answer comes to 20, so you can just jot that down somewhere. Guess if you're not sure, sine 30 is a half. So this becomes 40 times a half, which is the 20 that they're telling us it is. Part B, and I've actually cleared the screen because I need quite a bit of space for this question. So we know from part A that this is 20 meters, and part B says find PB, which is this. And what we might do in a question like this is actually find all of this length, because if I look at this triangle, it's just a right angle triangle, and I know two of the sides, so I can work out the third. So this is 20, this is 40, and I'm looking for the whole bottom of the triangle. So let's use Pythagoras. There is A, there is B. Remember, longest side is C. Rest don't matter. We'll write A squared plus B squared equals C squared. A is 20. B is the thing I'm looking for. And C is 40. 20 squared, well, 2 2s are 4, and then there'll be 2 zeros on the end. Plus B squared. 40 squared, 4 4s are 16, and then 2 zeros on the end. And if 400 plus B squared is 1600, then B squared is going to be 1600, take away 400, which is 1200. And B, the entire length of this bottom triangle, is going to be the square root of 1200. Now, if we look at the form of the answer I'm looking for, there's no square root of 1200 in here. There's a root 3. So what I'm going to do is look at this root 1200, and I'm going to simplify it. I'm going to simplify this third. I'm looking for two numbers that multiply to make 1200. Well, I know that 3 times 400 is 1200. So root 3 times root 400 is root 1200. Root 400, I know from this previous part of the question, just reversing this will get me back to 20. So this simplifies down to 20, that's that bit, root 3. So the entire length of the bottom of this triangle is 20 root 3. Now I don't want the entire length of this triangle, I just want PB. So what I'm going to get is PB is going to be the whole bottom of the triangle, which is 20 root 3, take away 20. And what we've got is a common factor of 20. So I'm going to factorise that out. 20 times something is 20 root 3. Well, 20 times root 3 is 20 root 3. And 20 times something is minus 20. 20 times minus 1 is minus 20. This now looks very much like what I was asked for in the question. So in question 14, here we've got two straight lines. We've got y equals 2x plus 1. And if we know about y equals mx plus c, this 1 is the y-intercept of that straight line. So I know straight away that that line there is y equals 2x plus 1. What I'm going to do is look down here as well. Look at this inequality. We've got something very similar. Y is less than or equal to 2x plus 1. So that inequality matches this straight line. We've got a second straight line, 7x plus 4y equals 28. Well, that must be the other one. So let's just jot that on there. 7x plus 4y equals 28. And again, if I come down to the inequalities, 7x plus 4y is greater than or equal to 28. So I've got an inequality that matches the graphs I've got. The question says, by drawing a third straight line, well, it must be linked to this one. And the only straight line I can draw linked to this one is y equals 1. Just replacing the inequalities with an equal sign as it was in the other two graphs. So I'm going to draw y equals 1. Here's my y-axis. Here's 1. This is y equals 1. And I'm drawing it as a dashed line. I'll explain why in a second. Okay, but that is the straight line. Y equals 1. What we're looking for is a region R that satisfies these inequalities. And what you'll normally find on a question like this is you get a triangle enclosed by all three lines. And that is usually your region R. We do need to just double check that. So I'm going to just do that now. My inequality says y is bigger than 1. If this line is where y is 1, then everywhere above it, y is bigger than 1. So that's good. Y is greater than 1 is definitely above that line, and that's pointing at my region. We can check this blue inequality. My line is saying y is 2x add 1, and I want y to be smaller than 2x add 1. So if we just pick any point, let's have a look in this region. Let's pick this point. The y value is 3. The x value is 1.5. Should have picked a nicer point. Is y smaller than 2x's add 1? Well, 2x's would be 3. Add 1 would be 4. Y is smaller than 2x add 1. So that's good. That point works and it sits in the region. And I'm going to tell you now, if you picked any point in this region and checked that straight line, 7 lots of your x value added to 4 lots of your y value would be 28. And that's just confirmation that the pink region we've shaded satisfies all 3 inequalities. So that's the bit I've coloured in. That is the region I'm looking for. Just a quick note on why I did a dashed line here and not a solid line. It's because I just want y is greater than 1. If it said y is greater than or equal to 1, that or equal to, I would have done a solid line. If you look at this, or equal to, solid line. Or equal to, solid line. No or equal to means I do a dashed line. Question 15, and here we've got a cumulative frequency graph showing information about 80 students. And it says find the interquartile range. Well, the interquartile range is about dividing this cumulative frequency into quarters. So I'm not going to go halfway up to 80. I'm going to go a quarter of the way up and read across and down. If this is a quarter of the way up, this is halfway, this is 3/4 of the way up, and that's what I want for my interquartile range. I want these things called the upper quartile and lower quartile. So the upper quartile, 3/4 of the way up, the cumulative frequency, read across, read down. I think that's 71, 2, 3, 4. The lower quartile, 1/4 of the way up the graph, read across, read down. That would be 51. And the interquartile range is just your upper quartile, take away your lower quartile, and 74 take 51 is 23. Part B, and I've just cleared the graph so we've got a bit more space to work. It says the ratio of numbers of students who pass is 4 to fail is 1. So pass to fail is 4 to 1. And what we've got straight away is a ratio which has got 5 parts to it. We know there are 80 people in this graph. So what I'm going to do is 80 divided by 5. Well, 80 divided by 5 is the same as 160 divided by 10, which is 16. Okay, so there are 5 parts to this curve, and each part is worth 16. So what I'm going to do is break this scale up into 16s. Okay, so that would be 10, 11, 12, 13, 14. There's 16 marks. And we're going to keep going and mark off every 16 marks to split the scale into 5 parts. But actually, the question says, what's the minimum mark needed to pass? Well, obviously the lower marks are the ones that fail, and there's only one part that fails. So actually, if I just read across for these 16 people, that there is my minimum mark needed to pass. Anyone below this mark fails. So I can see that is around 48. Anywhere around 46, 48, 50 would get that mark. Question 16, and we've got a sequence. And we're asked to work out the next term. So always just have a look at what's happening between terms of your sequence. We'll either be adding, subtracting, or multiplying usually. How do we get to 5 root 3 from 5? The only way to get that is to times root 3. Does that work between these two? I'll just pencil it in. Times root 3. Root 3 times root 3 is 3. and 3 times 5 is 15. So that's what's happening between terms. We're timesing by root 3. Root 3 times root 3 is 3 again, and 3 times 15 is 45. There's my next term. Part B says find the nth term. Bit of a tricky one because this is a geometric sequence. We're not adding between terms, we're multiplying. And the nth term for a geometric sequence is AR to the n minus 1. And I'll explain what that means. A is your first term, and R is this multiplier that we've looked at. So what we're going to get, our first term is 5, our multiplier is root 3, and this n minus 1 just is what it is. You leave that there, okay? So that's still just n minus 1. Question 17, another little naughty ratio question here. We've got the heights of some shapes are in the ratio 1 to 4 to 5, and key thing is these are similar shapes. So these are perfect enlargements. So what I'm going to just jot down first, it's talking about heights, and heights are lengths, and they're in the ratio 1 to 4 to 5. Now, if my lengths are in this ratio, then my areas, which is what this question is ultimately about, are not in these ratios, but they're in these numbers squared. So I'm going to have my areas that are in the ratio 1 squared to 4 squared to 5 squared. And I can actually work those out. 1 squared is 1, 4 squared is 16, and 5 squared is 5 5s are 25. My volumes, if I needed to go into volumes, the ratios for the volumes would be 1 cubed to 4 cubed to 5 cubed. But I don't need that. I just need area scale factors, if you like. So this is how my areas compare. We're actually looking for the ratio total shaded area to total unshaded area. Well, if we call this middle bit 1 part, then this shaded bit in the middle would be the 16 parts, take away the 1 part in the middle. There is only 15 parts shaded there, if you like. And if we go further and look at this larger cross, then that's 25 parts, but I've got to remove all of the shaded region and the middle section, but I can actually just say that that's 16 parts because the whole shaded cross, including the middle, is this 16 parts. And 25 take 16 is 9 parts. If I want to do some total non-shaded area, so let's jot that down, total unshaded is going to be 9 parts added to the 1 parts. And then we know that shaded is just 15 parts. If we want shaded to unshaded, we get shaded to unshaded, 15 to 10. It does say give your answer in its simplest form, and these will both divide by 5, which is 3 to 2. Question 18, we've got a quadratic, and it's saying write it in this form, which is telling you to complete the square. This here is completed square form. How do we do that? Well, we're going to open a single bracket squared with an x in it. This 4, we're going to half, and it's positive 4, so we get positive 2. We're going to square this 2 and subtract it. 2 squared is 4, always a subtraction. And then don't forget this minus 16 just sits on the end. That's how to complete the square. Let's just tidy this last bit up. X plus 2 all squared is fine. Take 4, take 16 is take 20. Part 2, we've got the same quadratic, but now it's an equation equaling 0, and we're asked to solve it, giving your answer in surd form. Well, if we've just been told to complete the square, and we want a solution in surd form, we're going to use our completed square form in order to solve this. X plus 2 all squared minus 20 now equals 0. We'll just solve this. First step is to add 20. And we get x plus 2 all squared equals 20. Next step is to square root, undo this. And we get x plus 2 equals, now when we're square rooting 20, we need a positive and a negative square root. The square root of 100 is negative 10 and positive 10. So the square root of 20 is negative root 20 and positive root 20. Final step is to take 2 from both sides. And what you're left with is x equals plus or minus root 20 minus 2. And here are your 2 solutions. So I'm going to have the positive square root of 20. Take 2. And then I'm going to have the negative square root of 20. Take 2. Part B says to sketch the graph. And again, it's the same quadratic that we've looked at throughout this question. And if we're sketching a graph and we've already completed the square, then this here provides you with something called the turning point. Completing the square gives you the turning point. It's a coordinate. We need to reverse this positive 2 to negative 2. And this negative 20 stays. So that is the turning point of the graph. So I'm just going to jot that or guess where that might be. Across to minus 2, down to minus 20, somewhere around there. We also know the y-intercept of the graph. So this is my y-intercept. So I'm going to look for minus 16, which is about there. And this is only a 3-mark question, and we're not asked to show the roots. So we're not asked to show where it crosses the x-axis. So I'm just going to sketch this in as I've got it. We know it's a positive quadratic, so it's going to be this shape. We know where the bottom is, and we know where it crosses the y-axis. So we're going to get something like this. Through at 16, bottom out there, and then back up. So question 19, nice little circle theorem question. All this information is just explaining the diagram. So focus mainly on the diagram. It says work out the value of x, which is here. And if we look at just this part of the diagram, we've got a triangle, center to circumference, center to circumference. That there is an isosceles triangle. And if this is 57, then this is 57. And we're just looking for this top angle. Well, 57 and 57 is 114. I just need to do 180. Take 114. Borrow from there. 10 take 4 is 6. 7 take 1 is 6. And 1 take 1 is 0. X is 66 degrees. Just going to clear my diagram. Because now it says work out the value of y. Well, if we look at this shape, we've got a 4-sided shape with all of its corners on the circumference of the circle. And what we can look at is this angle and this angle. And those two opposite angles, they're the opposite angles of a cyclic quadrilateral, they will add to 180. So if I do 180 take 82, ten take 2 is 8, 7 take 8 we can't do, so I'm just going to borrow from that and get 17 take 8, which is 9. So this total angle, including the 57, comes to 98. So let's do 98. Take the 57 that we've already got. 8 take 7 is 1. 9 take 5 is 4. So this angle here is 41 degrees. We're actually looking for y, which is this angle. But what we've got is a tangent meeting a radius, and they always meet at 90 degrees. So to get y, I'm just going to need to do 90 degrees, take away the 41 that I've just found, and you end up with 49 degrees. It does not say give reasons anywhere for these angles, so I'm not going to bother wasting my time. I only need the actual angles. Question 20, we've got an algebraic proof, and we're looking to show that this expression is a perfect square, and all that means is it's a square number. Now, if you ever are not sure what to do on an algebraic proof, then just do any algebra you can. I've got some double brackets here, so I'm going to start by just expanding these double brackets. So I'll do that step by step. We've got 2x multiplied by 3x. 2x times 3x is 6x squared. We've got 2x multiplied by 2, so that would be 4x. We're now going to do 1 times 3x, which is 3x. I'm going to do 1 times 2, which is 2. We might also look at the brackets on the right here. We can do x times 3x is 3x squared. We can do x times 5, which is 5x. And then don't forget this plus 2 sat on the end, that's just plus 2. And even if I don't know where I'm going with this, I've just got marks for expanding brackets. We've actually got things we can simplify. 6x squared plus 3x squared is 9x squared. We've got 4x, add 3x, add 5x, that's 7, 12x's. And then we've got plus 2, which is plus 4. What we're looking to do here is show that this is something squared. And what I've recognised is I've got just a quadratic expression. I've got x squared terms, x terms, and a number term. The only algebra I can really do at this point is try and get this into double brackets, try and factorise it. So it's not an easy one. I'm going to start with doing 9 times 4, and that is 36. What I'm looking for now is two numbers that add to 12 but multiply to 36. And the only two numbers that add to 12 and times to 36 are 6 and 6. 6 sixes are 36 and 6 add 6 is 12. So these are my two numbers that I'm interested in. And what I'm going to do is just use these and rewrite this quadratic. I've got 9x squared. Rather than plus 12x, I'm going to write plus 6x plus 6x, just using these two numbers. And then the plus 4 still comes down. I'm going to split this in half. If we factorise the left-hand side, well, the common factor of 9 and 6 is 3. Common factor of x squared and x is x. Open up some brackets. 3x times something is 9x squared. 3x times 3x is 9x squared. 3x times something is 6x. 3x times 2 is 6x. Factorise this side. Common factor of 6 and 4 is 2. Open up some brackets. 2 times something is 6x. 2 times 3x is 6x. 2 times something is 4. 2 times 2 is 4. We'll see I've got matching brackets. So that is my first bracket of this factorisation. Where does my second bracket come from? Well, if I look at this 3x and this 2, they're in my second bracket. And what we've got is matching brackets, so I can rewrite this as 3x plus 2, and rather than 3x plus 2 times 3x plus 2, I can just write it as 3x plus 2 all squared, and that there is a square number. Why? Because whatever's in the bracket doesn't matter, I'm then going to square it, so I must have a square number. Final part of this question, it says the equation, this thing that we've just looked at, equals minus 12 has no solutions. Explain her reasoning. Well, we're looking for a negative number, and we know that all of this simplifies to that. And we're saying that something squared is negative 12. So in order to solve that, our first step would be to square root, and we can't square root a negative number. If I was to write 3x plus 2 all squared equals minus 12 and then try to solve it, my first step would be to square root, and I'd get an error straight away. Square root in negative 12 can't be done, certainly not at GCSE.